Oh, I love the memes. Let's test if I'm live, shall we? Yes! Oh, I love the meme. I'm gonna post the stream link. Probably both, but I'm gonna make a separate voice channel, separate channel in Discord right now that is streaming. Well, that didn't work. Setting up everything for the first time. So my var. What's really crazy about this is that I used to I'm on my other account. I'm used to streaming for like more people, so I'm like somewhat used to this. But this is gonna be like the third YouTube channel that I've started streaming on like fresh. Motherfucker. Yeah, I've never streamed on YouTube. This is my first YouTube stream. I'm going to add source, add audio output capture, comms, add la 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 la.
Seems to be working. I really should go to bed, but I wanna not. Your body just starts hurting when you just lay in a bed. I don't know.
RT, I don't need a hardware call stack. I have a hardware stack already that can be used as data and hardware. It's R14, bro. Bruh. Bruh.
Bruh.
Look at this R14. It's top of stack. You can just manipulate it there. And since return pointers for jump and link go to R15, you just do all you do is do a move from 15 to 14, and boom, your return address is now on the top of your stack, and then you can just do whatever you want, and you can know that yay, I can get back at any time.
Yeah.
Also, the YouTube chat will be easier for me to respond to than the sidebar for URT because I'm used to this. Nesting, well then if you want to nest, you do a call that puts your return pointer to R15, and then you move R15 to R14, and then you just do another call, and you just keep doing it, and you keep moving. R14, when you write to R14, it pushes to the stack automatically. Like it just pushes it onto your software stack. You define your stack pointer and stuff like that in control registers. And then once you define it there, then the top of the stack acts as if it is the top of the stack. So if you put it as your A operand, it peaks, so it'll read the top, and then it'll just like read, write, modify, or read, modify, write the top of the stack. But if you use it as a B operand, it'll pop. But if you use like an A operand of a move, for example, then it'll just push.
I want to screen share Discord as well. It kind of hurts my head when the visuals are delayed while you're speaking.
You said what about Discord?
You're not screen sharing in Discord.
Yeah. I don't think I have the internet here to do both.
Okay. That complicates things.
I'm moving in a couple months, and I'm moving to a place where I can get 2 gigabit internet for like $100. I'll be buying that the moment I move in. I'll be like, yes, give me please all the 2 gigs.
How much do you have now?
I have like 80 megs.
Oh yeah, no. You would have to stream at like 720p. Although you could probably put the Discord stream on very low quality and then it would be fine.
Artie, what seems more demanding on the programmer?
I think he was talking about you describing how to nest things with the stack.
Not now. I'm not getting more than 100 meg. When I used to live with my parents, I got a gigabit, and then now I get maybe 100, peak 100, but usually ends up being like 70 to 80 megs.
Yeah, that's not fun.
Upload is actually more consistent, so I'm gonna do both and just see if it ruins anything. No, my CPU. I don't want to fuck my CPU that much.
Generally RTOS the compiler takes care of the software stack, right?
Yeah, like every single modern system uses software stacks. Yeah. It's just mine is a faster. It gives it a much easier way for the user to pretty much have a managed stack without having to do anything, just reading and writing to a register.
That way, so it really doesn't put a burden on the programmer because the compiler takes care of it. But it does making the compiler harder, I guess. But not that that's really a big deal. I have I think I have a 500 meg line. Oh, I'm sick and I have to go sailing this weekend. I'm not feeling like it. So, tell me, what is a Runahead Queue, Mr. Capo?
So the Runahead Queue is like, you remember when I went over this last time? Were you here for this? Or did you leave? I don't think so. Okay, so you left. So for Runahead, currently we have a register file. Actually, what am I doing? I'll just erase this and just remake it. This is written like shit anyway. Okay, so we right now we have a register file, and in this register file we're just gonna put 4 registers for now. We have a dirty vector for each of these registers, That's it. That this is what we currently use in V1 to say when you stall. Okay. So
Okay, sorry. Yeah, the stream takes a while to catch up.
yeah.
But I hear there's a average file
We have
and
the dirty vector, and then then what we currently do now is if we have an instruction come in and a dirty bit is set to 1, and it requires like this is 0, 1, 2, 3. So we have like an add.
So let me guess. In other words, instead of stalling the CPU whenever something is dirty, you're gonna queue up the instructions.
Yeah, exactly, because it's running
Okay.
ahead. So instead of this stalling the CPU, this would go ahead. You would end up going ahead and you would take this instruction and put it off into a run ahead queue, which would be this.
Right, and then other things that are not dependent on that concurrency can just continue going ahead,
Yep.
right? Okay, that makes sense.
So this is the FIFO yeah. So essentially, you just do this. It's just the one complicated thing is that since you normally have a dual read on your registers for these values, right? You have the bits here set for like, hey, if this is here, but then you have a FIFO, and if you have an instruction currently, every cycle you're going to have an instruction. Like you just do. You're either you don't have an instruction because you're waiting on a cache or something like that, but you have an instruction somewhere.
Yeah, fundamentally there has to be one, otherwise the CPU is no longer, executing.
Exactly. So what you do is, since you're always going to have something here, if you check this instruction and this instruction at all cycles, and anytime this can go, this takes priority. Every time this takes priority. So it guarantees you forward progress. Because if you ever give this priority, then you could wind up in an instance where you never ever finish an instruction. So there's multiple ways to do this. The way I'm going to do this is in my queue, I'm going to have since I have an instruction right here that's 16 bits, I'm going to pad this out with 2 bits. So you have a 16-bit instruction. Wow. 16-bit instruction. And then right here, I'm going to have an A bit and a B bit. And these are just going to say whether, and this is just going to go in. So whenever you have a write into this structure here, it's essentially going to broadcast it similar to the way that like Thomas Zulo's does, or out of order shit goes. Normal stuff. It's just going to check whether or not the registers written here are hey Matt.
No.
Good morning.
We're live streaming.
I'm on YouTube. Check announcements.
Just so you know, I'll send you a link. There you go. Yeah, this is magnificently confusing, right? Watching the stream and your explanation ahead, because you're using the diagram.
I'll just fucking stream my goddamn screen in Discord.
Yeah, you might want to consider maybe streaming at 720p onto YouTube, and then.
Where did Matt go?
Oh, I don't know. Lower the qual on Discord. Anyway, sorry. Go ahead. Yeah,
that's a good call. I'll just go with like 720 because you don't really need much for this. So now you can be up to date. So what I essentially have is when you have this lead instruction, whatever's on the FIFO, you just let this constantly read. And there's essentially 3 bits. There's a valid bit, so that way you know whether or not the current instruction is even being written to or not. Like if it's even there. You have a valid bit, then you have an A and a B, an A valid and a B, or an A dirty and a B dirty. What this does is that whenever you write something back to this register file, so whenever anything gets written back to the register file, you're just going to compare that register to the register that's in here. So if this was the add R0 R3, this is just going to monitor every write and wait until you get a write on R0. And when you get a write on R0, it'll go, cool, it's going to mark this valid. It's going to mark this 0. And then once both of these are zeros, then it goes, cool, we're good. our instructions no longer dirty, so we can then just continue.
Is it worth it, though?
What do you mean, is it
Like
worth
to
it?
do this?
Well, yeah, the idea is that, like, right now, if we have, because you can do this and do like a 1 deep branch unroll for like 1 deep branch speculation. And it allows you just to, like, right now, if we have like if we do any like memory operations and stuff like that, and they're like a cache miss, we can move ahead of, we can if we do like a load into a, currently we can allow the user with the dirty system to load into a register, to load like 4 values into registers like 13, 14, and 15, 13, 4, or 11, 12, 13, and 14. Let's just say 11, 12, 13, and 14. You can load 4 values into there. You can do a load, and then do work on other registers. But at any given time, if any instruction needs to work on one of those loaded values, the system stalls immediately. With this setup, it allows the system to keep going ahead until you need the result of the result, if that makes sense. So we can't, since we're only having a 2 deep dirty buffer. So a dirty bit here means if this dirty bit is set, there's a dirty and a shadow dirty. I think I'm just gonna call it dirty and like muddy.
So if I understand this correct, right? What's going on here is that you're deciding where you're deciding where to do the out of order execution based on whether or not an instruction needs access to a register.
Yeah.
Okay, that makes sense. So in other words, this is your out of order execution system, in a sense, right?
Yeah. So like in this operation, in this circumstance, since this instruction was add R0, R3 came in, and it needs to operate on R0 and R3, and R0 is not there, so it gets pushed to here. This secondary vector that's associated with this, you have dirty and then you have muddy or whatever. I'm going to figure out some fucking word for it. This extra bit here, you set whenever you need to read this 3. So that way, if another instruction comes in that needs to write 3, then you stall. Because
that preserves concurrency, right? So that
yes.
There's no race condition.
Yeah.
Okay, that makes sense. I mean,
yeah. So that way, when we can support read after reads and read after writes, but we can't. As soon as you have any write after write, we stall. But now, if you had a loop where you're doing like a few instructions where you just like grabbed something from memory, you did another operation on it, then you like stored it and you did something else, and it didn't really matter. That memory operation didn't really impact your total code string. You just pretty much said, hey, if this value's 5, like if my code has a 5 in it, for instance, then write this section to write this constant like ASCII string to memory, and they're all immediates. And you effectively queue up all those immediate stores and just do all of those based on that address, and it will just queue all that information up and just put it in the Runahead queue and do those instructions as it can while it's still running your primary code.
This is fairly interesting.
So it's not full out of order. Like you can't do full loop unroll. You can't do all the like the super crazy stuff you can do with modern stuff entirely, but it gets you close enough to where when you're on a small scale system, it's gonna give you pretty damn good performance.
A language like Rust that is very aware of what's mutable and what's not would have some great performance on this.
There was some research papers by Owner Mutlu and his PhD group, like years, I want to say like 7, 8 years ago, maybe 10 years ago at this point, that went into Runahead systems, and on their test cases, they compared a Runahead system that allowed you to run ahead. Mind you, their Runahead system's slightly different than mine, because they maintain state. So I'll give you the difference later. But they had I think it was like a 256 deep, or either 128 or 256 deep Runahead queue, and it involves nearly like 0 additional hardware. It's just effectively a queue in this comparison, and everything else downstream is the same. Nothing really changes. It's very little added hardware complexity. The biggest thing is the queue. So then they were able to match or beat Tomasulo's performance per watt and performance per area using this method, but it's just but modern compilers and stuff like that need to be more aware of this. And the one flaw that they had is, it's not really a flaw, they chose it for stateful. I don't care if my state's kind of dead. I have a way to recover state, but it's not like that clean.
Interesting.
But the way that they did theirs that made their state full is that when they ran ahead, as soon as they put the first instruction into the run ahead buffer, they would store that PC aside, and then they would just run the code ahead in like a secondary register file, and with the only goal of generating memory addresses and getting preloading like memory fetches and stuff like that. And then as soon as the run ahead queue was able to start running, like the first instruction became valid, it then cleared the entire run ahead queue, and it rolled back the entire register state to what it was when it started run ahead. So effectively, all it's doing is while the CPU is waiting on a cache response, it's looking ahead in the code itself to generate addresses and find the next memory thing, since the vast majority of your stalls are going to be cache misses. So if you can solve that by simply having your CPU run ahead of where you currently are to generate those cache misses, you can then you just, it doesn't matter if you throw away all of that work and you redo that work. The simple fact that you're not having to stall you're not having to run for 20 cycles, get a memory address, and stall forever because you've ran ahead enough, and that because you've done some stuff, and then you can't continue because you don't have time.
Really smart. So when you're not failing, when you are hitting cache, your processor is fast. But when you do fail, you spend that time to acquire accurate addresses so that you don't fail in the future.
Yeah, exactly. So you use your failure response time to mitigate future fails.
Cool.
I just got up to stretch for a second.
Okay. Hello, Data.
What?
How have you been, mate?
I've been pretty good.
Nice.
How you been?
I am really sick. Yeah.
That's no good.
No, it's not. It's not.
I just realized something. I don't even have the Discord linked anywhere on the fucking YouTube.
Oh, no, you don't have to get that. Yeah. You should add that in the comments, I guess. Comment. Yeah, description. That's the word. Wow, you would think after making YouTube videos for so much time, I would not get that confused.
Okay, so we have instruction, operand, and status.
You think Optimo and Martin will be joining us?
Optimo is currently going to the doctor because he's still sick for like the month.
Oh, he just spoke about that. Wish him luck, yeah?
Yep, and then Mart's in university, but he gets out of uni in like the next 40 minutes, so he'll be here at some point. We still got another 2 to 3 hours here, so Mart will most likely be here.
Yeah, when it's a little bit earlier, it's easier for me to attend. Yeah. New KSP is out.
I have a question. When you're on the YouTube stream, can you read like the text that I'm typing? And I have my remarkable 0 viewers right now.
Yes, I can. Yeah. I can read it. It's good. gonna go make some tea or coffee. Be right back.
Okay. I'm just catching up on a Discord. So we need to we need a broadcast monitor, which would be I feel like I need music or something. Streams always need music. I'm looking at the stream, making sure you can actually see. Right up, Brand Andreas. So we have two write ports. We have memory. Memory load valid. Okay, so load register address. We also need to input. What would be a good name for the other write port? We have a memory write port, which memory main load because it only goes used when you load. The other is just general. So I'm just put write back. Back register address. Oh, that's not a problem. I don't really give a fuck. Coolio. Why did I do that? see. Oh, I have one viewer. Welcome, one viewer. So what you up to, Data?
Working on test programs for the Rails emulator.
Nice, nice. Register right back. So we need... Let me know if you want me to mute myself in Discord. I'm just talking more since I'm streaming now. And at some point, I'm going to go through these streams and just grab like the video and like speed it up and crop and shit like that and use it for something. Use it to actually make good content. Fetch instruction. No, it won't. Hold on. That'll be normal. Yeah, so y'all have that up here. Yeah, that works. Let's see. I'm trying to figure out where in this pipeline I want to have this exactly get its inputs and outputs. So you have the instruction decoder, which can go parallel to the register file. Well, no, I needs to technically go after. My issue being that I need this to feed into here, but I also need this to then
I'm back.
Welcome back.
Me and my one friend, the one I was telling you about earlier, deployed a huge pterodactyl setup. Now we just need to get people to play on it. EEPROM, where memory goes to die.
Okay.
I was trying to make, like this EA, on those old games, yeah? But I was trying to make a joke like that, but it didn't work, so whatever.
Okay. This makes me happy. So so
Oh, Lucid Charts has been really good, like you said. One of my clients uses it, and it's really helpful.
Oh yeah, Lucid Chart. Like I know there's Draw.io and there's free ones, but Lucid Chart's just there's something about it and the ease of it and how well it works. Like and every time I've never gone to it, like walked away and come back to it a few weeks later and not had some new feature that I was like, huh. Some of them I don't use because they're not applicable to me, but there's always they're always upgrading it.
Yeah, it's pretty good. I feel conflicted on the inside.
Why?
I've been listening to a lot of German music, but I don't speak any German. And I'm not quite sure what I'm listening to, but it sounds very aggressive.
Okay.
I'm not quite sure why I'm listening to German music, but you know, where life takes you, I guess. So, Dana,
So,
do you think about getting two girls one day? Like children?
are you still streaming?
Yes.
Yes. It's a joke because of Data and Star Trek who had two children. Anyway.
Was that a data structure joke?
No, like Data from Star Trek.
From Star Trek. Yeah.
Yeah.
You know, it's funny. I still haven't watched Star Trek.
What?
Yeah, believe it or not.
Which
Listen,
wait. I've only seen like you're gonna hate me even more. You know the only Star Trek I've seen?
Uh,
The movies
Don't
that were
say
made
the
in the
original series.
2000s.
oh, dude, just no.
Like the
you're both
2010s movies.
heathens.
I've watched all of those amazing artworks.
This is bullshit. We need to just.
You're gonna kill me.
Yeah, no, I don't think we can be friends anymore. To be honest.
You know what? I thought those movies were fucking fantastic.
Sure, but Star Trek. There's so much.
feel like
Maybe we
I-
should start a movie night on the server and fix that, or a series night, whatever.
I
feel
would
like I probably
not
would
spend that
like
time to
a-
watch that show.
It's way too big. I feel like I would like it better than Star Wars though.
Yeah, I spent most of my teenage years watching that, watching Star Trek. Wow, blows my mind. I'm bored.
Well, that sucks.
I have
You're not
lots
a-
of work.
I was about to say you're not a bored, you're a person.
Thank you, good sir, for enlightening me about my self-identity.
Oh, that takes me back to Or. I would say dumb stuff like that all the time.
Mm. Hey, have you ever played Stationeers?
It rings a bell, maybe.
Not Astroneer, Stationeer.
Yeah.
It's really good. You wanna play? Do you own the game?
Say no.
Well, I'm busy working on the Rails thing right now, but
What Rails?
it's a little CPU.
Oh, yeah. Fun. That game, like,
Oh, that game, yeah.
that game's wild, dude. It's lots of fun. You will regret it because you will throw away a few hundred hours of your life.
See, that's why we haven't gotten Dwarf Fortress.
Why?
Because we know that if either of us starts playing that game, the other one will get that game, and like it will officially be unproductive members of society. Like there won't be any productivity until we feel like that game has been mastered and we've actually fully enjoyed it, and that won't happen in that game.
When I
No.
bought RimWorld, I blinked and 500 hours of my life disappeared. I don't know where they went.
I spent 500 hours of my life on Space Engineers.
I was about to bring that up because that's like
Oh, it's 600, yeah. Holy shit, I need a life. Oh, well, let's not talk about Counter-Strike, though. 1,400 hours.
oof.
That's it,
Yeah.
bro.
How much do you have?
On one satisfactory save, just in the time I spent streaming it, I have 1,600 hours in one save.
What?
Buddy.
Yeah, remember I streamed
Oh my
Satisfactory for 2
God.
years as like a part-time job, like 3 days a week for like 10 hours a day.
No.
Essentially like a part-time job.
No, let's not do that.
Yeah.
My most played game on Steam doesn't even come close to that. I think I only have like 1,300 hours in War Thunder.
Bruh, don't even get me started on Halo Reach. I have more than that on Reach.
I love Halo. Halo is the best game that has ever been.
If I still have, like, the
No, I
hours
think
in that.
Satisfactory actually takes Reach because it was a longer, because I actually had more free time because I didn't have school and stuff. So I was an
And this is, of
adult.
course, ignoring the fact that all of us probably have the most hours in Minecraft.
Oh,
yes, but
god off,
that's not
yes.
measured. Like, holy
If you
dude.
include AFK time, I have hundreds and hundreds of days.
Yeah. Mhm. I remember on the old server before the reset, I think my time spent in game was at like, oh gosh, I think it was at like 120 something days.
Yeah, we've reset the server like 4 times, and 2 of those times I've had over 200, and 1 of those times I've had over 100. Because it's been now 10
Jesus.
years, so I've had over, like, I think the last time I did the math, it was like a year and a half of online time. So like an eighth of my life in the last 10 years has been on OR, which is a huge asterisk on that, because the last like 5-6 years I have done like fuck all on there. So 99% of that time's front loaded.
Yeah, so for you and me, that's probably like bordering on, it's like close to 10,000 hours.
Yeah.
No, nice. That's wild, dude. I know. Man, I last seriously built stuff on ore before Johnny was banned.
For who? Oh, John A was banned.
Yeah, like long
Wow.
before that. Like, I don't know, maybe 8 years ago. It's interesting. Like, I knew about Capo, but
Yeah, it's
we
funny. We
didn't
talked
really
about this
interact.
the other day. Yesterday, he asked. I mentioned like how I know you and stuff like that. I was like, oh yeah, we met through like literally. Um,
How did we meet?
we met through Benny's Discord because I became admin. You were like a third
Oh,
person to join, and you like gave good ideas and you were really helpful. So we gave you
I
moderator and you
remember.
helped for a little bit,
Yeah,
and then I talked to you randomly in DMs over the course of like three,
a
four
few
years of
years.
just Benny drama and randomly poking
Drama.
like, oh, I see you're doing this is your status. You play that game? Yeah, yeah, yeah. Blah blah blah. Cool. And like that was the most of our interactions.
Yeah, I remember Benny. I had a great time writing the compiler on that, but that just the community stuff just spiraled out of control there, I
Because he
guess.
was never he did every time it started picking up, he would just disappear, and it made me sad.
Yeah, yeah, it's fine. I understand. Like life gets in the way, you know. I really hope he does a Vulcan series though, because Vulcan is cancer, and I don't want to
Yeah,
research
well,
that
he did
stuff.
that. Um, he did the blog that I ended up connecting into this. Like he did the
I
blog,
saw.
the initial blog post on back, and then over the next like 2 months, he released another two posts, and then like another month or two after that, I realized shit, I didn't set up the RSS for Discord, so I learned how to do RSS in Discord just to set that up, and then he's never posted again. And I'm like, God damn it, man. I did this for
uh,
you. I told you I made your community and I'm doing it and you're not here. Why?
I last played on Discord when Benny was making Minecraft videos. On Ore when Benny was making Minecraft videos. I have a like back then. I was in grade 8. Yeah, grade 8 in high school, and I didn't have internet, really good internet. I had like a 20 kilobits per second connection or something stupid like that. And so I went to an internet cafe and downloaded all of Benny's videos on building a redstone computer,
Yeah.
and then I onto my phone, and then I would sit in class and watch his videos. And instead of building it in Minecraft, I would just draw out the logic gates on a piece of paper in school. So I effectively, and after that I just continued. So I effectively spent most of my time in high school just drawing CPU stuff on paper.
Yeah, see when my job that I had for a while was like had involved a lot of driving and travel and stuff like that. So I um so since I hated the driving and stuff like that, my dad ended up doing it for me. So, but since he ended up driving all the time, that left me with like multiple stretches of 2 hours a day there and back. So half my workday of just sitting there in the van, which I could use. We listened to audiobook, watch YouTube videos, but instead I would just like look up research papers on like how does that out of order execution work? How does this work? How does that work? I figured I didn't go to college and I have free time at work where I'm just sitting here. I have unlimited access on my phone to internet. So
I have a friend, uh, um, Kevin. I haven't. Well, I've lost contact with him. It's been a long time. But he was the most talented programmer I knew, like I've ever came across. Like he's really ridiculously good. He's very obsessed with radio astronomy, and he was a paramedic, right? So he would answer 911 calls. Um, but he lived in a small town, and it rarely happened. Um, so yeah, he would just sit there with his laptop at the operator center thing, whatever. I don't know what it's called, and then wait for a call to come in. And in that time, he would just program, and He spent like 3 years like that, just programming all the time.
There you go. I at least have a background on the top of the stream now instead of just a black fucking bar.
You should take a screenshot of the lucid charts or the
I will, like, I plan to make this like eventually have this all set up. Like when I was doing the my Satisfactory streams, I wish I still had some of those. I need to check if they're still uploaded somewhere. I know I downloaded a few of them. They were really, really fucking cool because like I had like a banner up top that I custom made that had. I could probably log back into that account at some point on the Streamlabs. It's effectively the overlay. Where's Milton? Milton, there you is.
Come on, wherever you are.
So I had this, and then I had a little banner at the top that was like this, and this texture of this banner was directly ripped from the game. It was one of the wall panels from the game, and I put a black gradient that kept black and went out on both of these sides. And on one of these was current viewers, and the other one was like last subscriber or something like that. And then right here was like the Satisfaction Labs logo. Chat was here, and it had like a nice little overlay on it. My camera came in down here, and then in this entire corner right here, I had the person who made the online Satisfactory map. I got him to add a custom background that was a constant color, so there was nothing but your stuff. It didn't show any of the map, just your placement. And then I was able to chroma key out that background. So as I was working on my trains, my map, there's pretty much like a transparent map right here that just had, and since the tracks came out in pink, you effectively just had like these trains and stuff like that just looked like they came through on this. And as I would like do work on each of these things, I would shift this map around. I'd go to that tab and shift around. So as I was working, I would do this, and I would have like a highlighted circle on the stream. I would shift around. That would be like, hey, I'm currently working here, and you could look around and monitor my progress. It was a really nice layout. I loved this layout.
Very cool.
But yeah, the overlay map was like, I loved it because people would always ask me, oh yeah, can we see a map update? Can we see a map update? So instead, I would just every like 10-15 minutes or so, or every like 30 minutes to an hour, I would just upload. I would take the save, upload it, and refresh the map, so that way you would, and then I would zoom back in on that location so you could see what the status is.
Very cool.
I'm curious.
I feel like I'm dying.
I don't know what. Please don't have Fog of fucking War on. I'm curious how Edge runs this. It should run it pretty well.
Still don't know how I feel about you actually using Edge in an unironic way.
So this is what I would show on stream. I would have I would choose plain background. And since I had all these train lines running at all times, or like I was working on them, wherever I would be working on the map, I would just like zoom in and be like, okay, well, right now I'm currently working on like this intersection. So I'd zoom in here, and then this map would be cropped out and just be there overlaid in the map with all the gray being just transparent. So I loved it so much.
Cool. Maybe I should spin up a Satisfactory server and we can all play.
There's the Sat Labs community that I like own has a community server that's always up.
Yeah, I don't like playing with strangers.
I haven't looked at this junction yet in here. I like that. That actually looks rather nice. Yeah, I'll take that. That looks a lot smoother than I thought it would look in here. Okay, that's enough distraction.
Hello, RT. What up?
Welcome back.
You ever watch Star Trek? Like all of the series and stuff, not just the movies? No? Oh, I almost thought I found a man of culture, but oh well. Worth a shot, though. I'm not that old either. How old are you, mate? It's a bunch of new Star Treks. Oh, you're young. Okay, fair enough. Yeah, you're really young. You're making me feel old. Wild to think that people were born in. I'm 24. Like, that's an old, I know. But, you know. It's just strange. Normally people are like, oh yeah, I was born in 19 something. And now kids are like, oh, I was born in 2008. And I'm like, what?
I know, right? Like my entire life I've grown up with people saying, yeah, 1990, like in the 90s or earlier. Now, like meeting people like, wait, you were born after in the new millennium? Wait, what? Like that's a thing,
Also, I'm not a boomer, damn it.
right?
Yeah. Steve Capo's old though. I think like he's in his 30s or something before these.
Motherfucker, no. I'm not 30 yet. I'm not 30 yet. Don't even do that to me. That's some evil shit.
I'm joking. I'm just yanking
It
your
makes me want to
chain.
cry.
The only thing, a person I think that's actually old is Optimo. He's like in his 40s, I think. I was born October 11th, 1998. So. Why? Oh, buddy. That's weird. But I mean, whatever floats your goat, right? It's fine. Nice. In x86, is there an I can't remember. Is the call opcode and the rate opcode like an assembler thing, or is it an actual opcode in machine code? Oh, it does appear to actually be an instruction in. Yeah. Okay. Huh. What's your favorite food, RT? I wonder if I can guess where you're from based on your answer. I doubt it, though.
Well, I mean, if you're in America, your food could literally be fucking anything, and then your question's null and void.
I know, that's
Because,
what I
like,
said,
you could, you could name any food, and you'd be like, oh. Oh my God! Don't say that. People can be 23 and born in this millennia. That hurts my soul.
Also, I think it's 22, not 23, but anyway.
No, you could be 23 because you could literally have been born any time before today's date and turn 23 this year.
Oh, you're right. Yeah, I'm bad at math. Okay, but what's your favorite food, mate?
For the one person watching the stream, which is probably ready, He's talking in Discord chat.
Right. Yeah. Let us see if I can guess based on what your favorite food is. Okay, masala. I really like masala tea. Yeah, I eat a lot of curry. Yes, I do. That's not very helpful, but let's make a guess in any case. Can I get 3 questions? Okay.
Is this like GeoGuessr Food Edition? I'm gonna guess where you are simply by you telling me your diet for the last month. Let's go.
What would be considered a staple where you're from? Like, not necessarily like a specific dish, but like, is it potatoes, rice, like. If I say, you will instantly give it. Okay, fine. Are you in the southern or the northern hemisphere of the planet? It's half it. Northern? Oh, interesting. Okay, let's open up Google Maps. Wonder what happened if I put RTYYYB into Google Maps. Will it tell me where you are? I checked. That doesn't work. Damn it. Oh no. Let's see. It's northern hemisphere. Oh. Ooh. I have a feeling are you in an EU country? Yes. Okay. Netherlands? No? Shit. Last question, yep. Oh, wait a minute, one second. It's not. I don't know if this is useful, but do you speak a Germanic language? Does your language stem from Germanic roots? You don't think so? Okay. Well, then are you in Hungary?
Hungary. Hungry. Hungry.
Nope. Okay. I don't know. I failed. Where are you, mate?
That put a song in my head, and I can't think. Like when you said Turkey, and it put a or Hungary, and it put a song in my head. And I can't think of. All I know is like dun 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 dun. And I have no idea what the rest of it is.
You're British. Oh, you mentioned that earlier that you live in Britain. I'm stupid. Also, you do have a Germanic language. I do believe English is a Germanic language. Yeah.
Yes, it is.
Yes. So that's why I excluded it from the list. Fair enough, but okay. Yeah. Nice. I have a programming friend in the EU. His name is Oliver. Nice, dude.
Dun 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 dun.
Okay, you want to play reverse food guesser? Go ahead.
Are you gonna guess where you're gonna get
Come on, live a little. Try and guess. Ask me 3 questions about the food in my country. Or just 3 questions in general. Sure, why not? Your goal is to not live a little. Nah. Okay. Um, just kidding. Okay, go ahead. Pop in with your 3 questions. If I could live anywhere, I would live in like Svalbard or Iceland or something. I don't know. I would probably have to say dumplings or pasta. Although you have an unfair advantage because you can hear my voice and you're only typing in text, so my accent does quite give it away quite a bit. Oh, it doesn't? I am 6, so I might sound a bit odd, but yeah. I'll give you a freebie. I'm in the southern hemisphere. That narrows it down a lot.
So this is the new pipeline, by the way.
Oh, with the instruction queuing stuff?
Yeah, with everything properly and like. Yeah,
Oh,
everything
yeah, so
properly installed.
that is cool. It just clicked for me what you were trying to say earlier. That what's nice about doing it this way is that you don't have to plan ahead. It slots in on the FFIO system, so you don't have to take it into account initially when you're designing your CPU. It's something you can add in later without having to redo everything.
Which part are you talking about?
With the run ahead thing?
Yeah, like the run ahead, all you have to do, well, you have to do a few different changes. Like I have one extra bit in the register file for statuses versus just
Yeah,
the
yeah, but I mean, like,
standard.
it's not a huge.
Yeah, no, the things
Yeah,
in
I mean,
pink are the only things you need.
Yeah, that's interesting. Yes, it's.
Well,
I
this
mean,
also needs to be colored pink.
a southern. What's it called? A latitude? Yeah, latitude. I think latitude.
The pink is all run ahead stuff.
Makes sense.
Yeah.
You still have 2 more questions, RT. I like most of places is in the northern hemisphere. So you're kind of lucky, no one. Yeah, one of those are correct. It is South America or Africa. Oh no, I'm not gonna tell you that. Giving you the continent is cheating. Okay, fine. It's in Africa. I'll give you a hint. My native tongue is based on German, Netherlands, Dutch, I think is in English. Yeah, German, Dutch, and I think it's French as well. Some French. This is what my home language, the roots languages that it comes from. That should be a dead giveaway.
I'm really glad I find it funny. Like the last time I tried to make this diagram, yeah, Artie, we've literally talked about where he's from like a million fucking times. I ask him to
Yeah.
cuss me out in the local language like every couple weeks.
Also, you probably have seen me live stream. I do have a presence on YouTube. Not much. I haven't done anything.
Well, you did here. You literally took us outside and showed you like your entire like compound that you live in.
Yeah.
I say compound because of the fence.
Listen, to me, it's just a house.
The fence is like you could stop a zombie apocalypse with that fucking fence, bro. Come on now.
Yes, I'm from South Africa. Yeah.
I think one of my things I said probably to cuss me out in your language gave the hint away.
Yeah.
But anyway, yeah, the CPU should be really fun to build.
Wow, you're
5-stage
building it at the
pipeline, and
moment?
each stage is much more balanced now.
We should start over. Take all the lessons we learned.
That's what I'm doing. That's
Wait,
what
what?
pORC2 is.
Oh, is it like a fresh start?
Yeah, because this is pORC1's pipeline. This is the working CPU's pipeline that we have right now. And then we're going to this one.
No, I should listen more when people speak.
And like the ISAs.
Oh, so you just like copying over the ALU blocks and the register files, and that's about it, right?
No, I'm not even. Every single module I was using, I'm going to rewrite because a lot of those modules were written extra, like they were extra sized, and I overdid stuff on purpose just to like teach people, since it was like a teaching how to use System Verilog and think through things build. But this one's going to be built for like actually kind of getting clock speed, since the other clock speed was shit. But this is V1's instruction set. And like
I remember I wrote an assembler for it.
Yeah, and they changed a little bit, but now there's pORC2, which has has two more major opcodes: privilege and load shifted byte R1. Has the top of the R14 is now a stack. You have a stack pointer which you can manipulate with swap stack pointer instruction. Stack pick and stack place is a load and store that's a direct offset to your swap byte, and the stack pick and place works on machine native size. So whatever your native bit width is of your machine is just going to use those. It's not going to be like stack.
That's really neat. So normally the compiler would offset, would calculate the offsets, right, and then do an offset dereference. But if you have a native instruction for doing that, it could be a lot faster, right?
Yeah, so right now you do a swap stack pointer instruction, and then it has a stat cache that it's going to manage. That's to make it the top of the stack visible for R14, and that R14 is going to be just operated on. And if you want to stack pick or play, you can operate on the top of the stack just by using R14. But if you knew that like you were like a call routine, like you knew you were a function, and you have like you have your return address at the bottom of your stack, and you have like 6 values above it. You could do a stack pick 7 and grab the 7th value, which would be your pointer, straight out of the stack, and just read that value out of memory without having to manipulate the stack at all. So it's pretty much
the only thing that saves is it saves an addition operation or subtraction operation, and then it
well, no, the pick and place is just a load and store. Yeah, it does replace that. Yeah, you're right, because you would have to read out the stack pointer. You'd have to swap stack pointer, add or subtract your offset based on if your stack is growing up or down. Go to that, then load or store to that value.
Yeah.
But there's a setting bit in the CSRs that tell you whether or not the stack grows up or down, so it automatically manages all of that for you.
That's interesting. I wonder if there is a way. So, like, an interesting thing is, right, if you want to make a struct that is really fast. Um, that hits cache, that fits inside the cache line. You make sure it's mod 64, right? But so what the compiler does to facilitate stuff like that is it pads the struct. So what you would need to do to use that opcode on a regular basis, outside of special cases where the struct has fixed with fields, or
The idea is that this would just be like for a function that you'd call, and then the function would know exactly what type of how its data structure would be in the stack anyway.
Yeah, but I mean, you do allocate structs on stacks as well, no?
Yeah, but like if you're calling a function, you should just make sure the struct on the stack is the struct that function is expecting. If not, you fucked anyway.
Yeah, then you have to manually do the offset calculation. That is true. Well, maybe your ABI for your processor could define that arguments and return values, because nowadays, languages have multiple return values. So arguments and return values are passed and affixed with on the stack, and then locals are offset calculated, so that those can be any size, but your parameters generally gets passed as fixed with fields. But yeah, that would be fairly wasteful, right? Be right back.
Okay. La di da di dee, la di da di dee dee. Okay, so then I need a fuck it operator.
You know what I just realized?
What?
There's a way you could make the instruction better.
How?
So the thing is that the arguments, return values, so what the function is returning, and locals are fixed. They're compile time metadata, right? So you're not gonna calculate a runtime offset. It's a fixed offset. So the compiler always knows the current stack pointer minus a fixed.
Yeah, you just
value.
load immediate.
Yeah, load immediate, right? But so the one of the primary functions of your opcode is that you're multiplying the architecture's bit width by some number, right? Where that is an intermediate. But what if instead you didn't multiply it so what you're doing, you're taking the stack pointer plus or minus, depending on that bit that's set, right? The bit width times so essentially size t times the number that's the intermediate, right? So instead, just remove this times the size t, because the compiler has to know what the target architecture bit width is in any case, right?
So you're just saying make the offset just by byte address, period. And if you're a 16-bit system, just use it. Just adapt accordingly.
In the compiler, because the compiler already has to know that information. So that way you're saying from the stack pointer load an intermediate offset.
Yeah, I mean that works and everything like that. The main yeah, that is easiest on also the design side. The only thing you'll have to know is that if you do a stack pick or stack place and you're a 16-bit system, you're going to be modifying that address and the one after it, because it's a 16-bit values natively in the stack, because it's your stack bit width, the element bit width of your stack element bit width is always going to match your system bit width.
Yes. So
yeah, and that's fine.
Relevant. Yeah.
Yeah. So instead of having that and say, hey, since you know this, here's a thing. Yeah, I like that better, because that means the same code can run on any system, more or less. You don't have to adjust those instructions.
No.
The adjustments have to go elsewhere, which is fine.
Fine. And it has the same level of optimization. There's no difference between the two in terms of. It's just that now compilers can actually use this opcode all the time for all stack indexing for local return values and arguments, because it can pass an arbitrary offset.
I used to be really afraid of using long opcodes, like long names for operands, or not for variables, I mean, but then I realized that sometimes it's just good.
Yeah, no, like descriptive variable names are really important. Yeah.
So I'm going to add 4 bits to this. I'm going to go to 19.
Is your stack backed by RAM, or
yes?
Is it a stand? Oh,
it's just straight cached. It's just a cache of your memory.
That makes sense.
So it holds 2 cache lines, and you effectively work through one of them. It'll hold probably either 2 or 4 cache lines, and as you're in them, it'll like it'll make sure you always have at least 1 cache line ahead of you and behind you of where you currently are. And then whenever you swap the stack pointer, it flushes that cache to L1 D cache and grabs the new pointer data.
Oh, that's interesting. the stack pointer and the base pointer, I don't know what the equivalent is in your architecture. You always subtract the local size from the, I can't remember, is it the base pointer or the stack pointer? The stack pointer, and at the start of a function. That way, when you call another function, you allocated space for your locals, right? So you could use that fact to better predict where the cache line is going. Anyway, not that stacks are already so predictable.
But yeah, this is explicitly the architecture itself knows that instead of just being a stack pointer and stuff like that and trying to tag which one of these things, it knows that this entire line is for the cache. This entire line came to or from the cache.
Yeah.
So so what I'm gonna do is, in order to make this work on the fast RAM structure that we realize, is that you just constantly have the value, make sure it reads out at all times. I was gonna use this value to constantly read the instruction out. Actually, no, I'm not. I'm just gonna say fuck it. So you have like a FIFO right here that'll read and write and stuff like that. And you duplicate whatever value is on the head of the FIFO into this buffer. And then you really just need to write these 3 values. Yeah, that's the solution around what I was fucking complaining about. Okay, yeah. So you pretty much you write the upper 3 bits of this vector, of this entrance, into these 3 locations. Whenever you get a new value out of the FIFO, and then as you compare the instructions and stuff like that against this, you pretty much will read out. You'll have a operand comparison where you grab the instruction that's the current value being read out of the FIFO, and you compare the right bits against the register being written to. God, I feel like I'm special. Oh, hey Hazard, what's up? Have you learned OEE in the server? Learn what?
Yeah, I don't know what OEE is.
I'm guessing out of order execution.
Oh, okay. Yeah, probably. Works. Yeah. Yes, you can in that.
Someone in the Discord's asking what they need to know for out of order execution. Do they to listen? How's that?
Like
pretty much basic pipelining and how forwarding works. So if you understand the concept of forwarding and why you need to forward, then you're good.
Depends on what you want to do, mate. Do you want to make a CPU that is out of order? Then start by making a pipeline CPU.
He's not in chat, so.
Oh, okay. Well.
la 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 la. I'm gonna make the run ahead depth parameterizable. I'm gonna go 32 deep. I have no idea if that's a good number, if it's a bad number, but at some point I want to have any questions? So what I'm gonna do, since people can watch these streams at a later date, I'm gonna make a new forum channel that's gonna be like session streams, and every time I do a stream, I'm gonna make a new I'm gonna make a new one of those. If that makes it.
Yeah, you're gonna make a new post. That makes sense.
Yeah,
I
a
was
new
muted
forum
and
post. That way, if someone's like goes back and watches the stream later on and goes like, "Hey, at this time, say if I have a question, they can go in there and ask about it."
yeah, that makes sense.
Who is still no?
Oh,
Oh, Skater. I was wondering who that is. Fetch instructions valid. Operand A status. Operand B status. Fetch instruction. Okay. Ding 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 bing ding 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 ding.
I'll add an opcode. So add some ROM to the CPU, and inside that ROM, pack a 128 128.
Don't die on us.
Yeah, let me.
I'll be back in just a second.
Sorry.
Let me stretch.
What I was saying, right? Take a 128 by 128 bitmap and shove it in a ROM and then add an instruction and put it in that bitmap includes the shit logo, right? The learn to do shit logo. And then whenever someone calls it opcode, it will write it to some address in memory.
Baba Booey.
Like Kappa.
What?
You were missing when I was talking earlier, so I'll just repeat myself. Add a ROM to the CPU, a small ROM, that contains 128 by 128 bitmap, where we put the learn to do shit logo in, right? In there, and then you add an instruction to write that to some address in memory.
So it just literally writes the shit emoji in like ASCII, or in just a bitmap, just a black and white shit logo.
No, you can use 32-bit colors, and then if you allocate an array that's 128 times 128 times 4 of memory besides ROM, then you can pack every
Well, see,
color.
the thing is, I don't need that. I need a 128. I need 128 by 128 pixels. Yes. However, there's only one, two, three, four colors in the entire thing plus transparency. So I can use a 3-bit code, and then just concatenate down the 3 bits of what color it is, and just have it deconstructed outward. And I'll probably go to 4 bits to make it easier to decode on a CPU, but just have it be 4 bits, and then
I would recommend doing it in 32-bit color because that's how most libraries and operating systems and stuff.
Well, Well, the thing is, I would allocate in memory.
Yeah, no, the output code.
Yeah, the output would be the right colors, but I would store locally just 4 32-bit colors, and then have a 4-bit one-hot vector that says, hey, whichever bit's on, submit that color. If there's none on, it's transparent.
What I meant is don't make it a 4-bit output.
Oh yeah, like no, I see what I know what you mean, but like locally, I could drop that substantially. Yeah, that would be what's 128 times 128.
Where's my calculator? Oh, you have one. There you go.
128 times 128 equals times 4. That'd be 64 kilobits of just data to store that compressed code.
Yes, but what you could do is you could prefix it.
Run length encoding because they're all in such large areas.
You can actually prefix it with useful information like the CPU's model number, how much the bit width, so like general CPU info.
Yeah, just
plus
like a
the
system
bit width.
information area that's maybe like a 4 kilobyte space, and then in like the last kilobyte I have like a run length encoded learn to do shit logo.
Yes, and then that would be like the CPU info command. And when you call the CPU info command, it writes to some address, which is the intermediate that you give to the opcode, that block of information. And then the operating system can parse that out, right? And then give that to people. But yeah, that would be fun.
That'd actually be really funny. I'm just standing up and stretching for a little bit since it's been like an hour and a half. But
Cool.
I should be able to get the tail and head written real quick, and then that would be. I just need the conditions on those.
Would you like me to quickly slap together a script to generate the bit stream, the packed bit stream?
If you want, it needs to be run length encoded, and we can think of a format. It could be like a 16-bit value where the first bit tells you whether or not it's Then you just be like a 16-bit value where you have like the lower 4 bits being what color you are, and the upper bits being how many pixels to go, how many pixels ahead you are of that, and then yeah, it could be just that easy. Then you have like an upper of like 12 bits that say the length, and then you have the lower 4, and if it gets to the edge of a line, it just wraps around because the transparencies and stuff wrap around to the edge, and so that would work perfectly.
Yes. Yeah, I think I'm gonna stand up and stretch as well for a while before doing that. Anyway, be right back.
Sorry. Okay, there you go. I got tired of all the fucking snippets putting me at the end. Also, one thing I'm changing substantially between these two ISAs is here we had the register, all the stalling logic happened with the moment you read the registers out, and then forwarding was after it. But if let's just say you were writing back to registers on that cycle, as you were going through, it would show dirty, but really it'd be fun. Like the forwarding would catch it. So what this allows you to do is it checks if your operands are gonna, instead of being clean when you read them, it checks if they're going to be clean on this cycle here. And if they're not clean at this time, then your instruction gets redirected. So effectively, we're just selectively exporting instructions, like killing them here and then just redirecting them up into this queue to then be refed in later. Oh shit, I also remembered I need to... Excuse me. There we go, right back. I'm thinking about an edge case that could happen. If you mark a register clean here, as like register 5 is going to be marked clean on cycle 6. F0, F1, D0, D1, E. Okay. Okay, so we have these stages, then we have execute. If we have our run ahead queue, and then we have our instruction cache. These two come together. So then if we have
FIFO, I smell the blood of a race condition, yo.
there is a race condition, because if you put in an instruction here, like let's say you have an add that comes in, and then it comes into fetch 1, and then decode 0, it comes in, decode 1, it then gets pushed to the run ahead, so it then gets asterisk, right? Because the value is not ready here.
I just sat in front of my desk.
If you have
I
a
was just making a joke, but there's actually a race condition.
there is.
Oh no.
So let's say you have these subtracts that come through, right? And let's say earlier in the code there was some load that went like down here, and this is what causes this race condition up here. Okay, this is what's causing this to stall. Oh. Huh. No, I think the system that we made already counts for this. So my thought is, right, let's say we have another like increment that comes in here, and I'll make this increment blue. So we have an increment that comes in, and this increment writes the same register that this load writes to. Okay, so this I comes back, and then it's written back right here. Okay, so in this clock cycle, this comes back, and then this comes back too. Okay. Or actually no, this load comes back in to this cycle here. So the load gets ready on this cycle. That means the add can get back into the pipeline right here. But by the time when this gets through the pipeline, by the time this goes through the pipeline, it's going to read from the registers. It's going to read from this valid register on decode 0. Here. So it's going to read the value from there, even though, see, the race condition I was worried about is that since this actually became cleared, since the dirty bit 4A was cleared by this load, that then this instruction would come through and be able and like come through. But I just realized that the only way this is an issue is if I were to write to the same register, and then A would get the wrong value, or if A would get from its read operand, if A would write to its read operand. But if I is writing to the read operand, remember, if we have any write after write hazards, it would go to the Runahead queue. So this I in this case would actually have been stalled out into the Runahead queue if it read the same operand, or if it wrote to the same operand that A needed to read. But if it wrote to the same operand that, oh yeah, no, that's fine, because it's a 2-operand system, so all operands are, the write operand is also a read operand. So yeah, this would actually have successfully pushed this out into the run ahead queue, and then I would have come in and start issuing. It would actually purposely go like this because of the way I have the dirty bits come in. it would have stalled out until I could have gone here. So these would have automatically been bubbled. However much time this is would have automatically been skipped because it would have detected that I is trying to write over an operand that A is reading, and because we only go one deep and register writes. If you go more than one deep, you have to track too much states. Yeah, that actually works out. Having that just second the shadow status bit works out perfectly. I need to make a note about this. Okay. There you go. Actually, whoa, hold up, wait a minute. Move this up, this up, move this up. There you go. That line does not need to accidentally look like it's going into the wrong thing. La 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 la. You can stream, RD, I don't care. It just won't, it's probably won't show up. It's not going to show up on YouTube, but I don't care if you stream in here. There's no like extra restrictions for this channel. It's just that if you talk in here, your voice is going to be streamed onto YouTube. That's why it's big bold streaming.
Yeah, so remember not to say mean things about my mother. That was a joke. You should laugh now. Come on, I know you wanna.
Okay. I'm glad I finally got the streaming stuff set up in the schedules.
Yes, so that I can attend.
I fully understand wanting that though, because like I need that. Like I have schedules set up for even though I have calls every week for work, I always still double check. Like I always set up an alarm for everything that I need set up for 24 hours in advance, 2 hours in advance, and 15 minutes in advance for everything.
Nice. Oh, you want to see something cool?
Maybe.
Let me find it one moment. Will it lurk upon your soul? Okay, I took this picture. Oh, let me put it in the sidebar instead, I guess. Yeah, so everyone can see it. There you go. Isn't that cool?
Un momento, por favor. Okay. Excuse me.
All right.
Oh, hold on. I'm going to simplify this. Instead of having it 3 gates deep, I'm just going to have it be 2 separate conditions. Da da la 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 da 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 da.
Sailing is so much fun.
So if the instruction's valid and operand A is invalid, store to it. Or if it's valid and operand B is invalid, and then if they're both invalid, it's going to ride anyway. Perfect. Okay, reg, multi-bit, FIFO, index, bit width.
Good morning, Vietnam.
He's in the house.
Hi, Ivar.
Hi, Ali. How's life been? Yeah.
How's life been? You know,
I don't. That's why I'm asking.
you know, it's been.
It's been.
Yeah.
Has it been good? Has it been bad? Has it been average?
You know,
Luister, ons gaan 'n probleem hê as jy anders so antwoord.
I'm sorry, I can't speak Afrikaans.
Yes, well, anyway. So life has been average. Is that what you're saying?
You know,
Oh, for
it's been life.
I am, therefore I am. Is that what you're saying? Yeah.
I am, therefore I am, and because I am suffer.
I'm
What's
sick.
on my pants? Damn it!
I don't know where your pants are.
I found my pants. Hi, Geo.
Hi.
What's poppin'?
Not much.
Base?
I'm thinking through something. I'm thinking through right now.
Okay, I won't interrupt your thoughts.
Yeah, just give me a second.
He's popping through his conditions in FIFO. Okay, let's play.
My
Guess
lighter?
Word. Why not?
Okay, cool. I was just trying to figure out if I needed one or two stalled flags, like if I needed a front end and a back end, or if they could both take the same stalled condition.
That is probably cache or instruction ROM or RAM. Some kind of a storage.
So what was that
Yeah,
picture you
okay.
sent me again? Myvar, I just looked.
Oh, the picture of the mountain, yeah?
Mm-hmm.
Yeah, you like it?
What is it?
It's a picture of Table Bay. I was out sailing near Robben Island and I took that picture.
That's beautiful.
Yeah. Sorry, say again, Ali, you broke up? Dude, that looks like...
I know what it is.
It's probably more memory of some kind or a comparator, maybe? I don't know. What is it?
Do you want me to say? I can say. Call stack.
Call stack. So more memory. Nice.
Call stack and data stacks.
Yeah. Big
Let's
things are
look at
usually memory, right? That is a register file. No? Or yeah. Oh yes. Okay. Yeah. That's too structured to not be a register file.
bad.
That looks like comparator logic. Yeah. Okay. That looks like a decoder of some kind. Yeah, kinda. Okay. Condition checker. Oh, I guess that's okay. Oh, I've seen this pattern before. Oh, that's a decoder, right? No, that doesn't make sense. No, I'm stupid. No.
That's a unary at. No, it's not.
No. Oh, that's a shift register. That is a shift register. No? What? Okay. What
Is
is
that
it?
just wire crossover? He's gonna tell us because we made too many guesses.
Yeah.
20 questions. Is your character real?
Oh, it's a binary counter. Yeah. That pattern is unmistakable. The moment you see the lights counting up, yeah. Now, either that is another binary counter. Oh, isn't that just a bus that changes directions? No, no, that doesn't make sense. Oh, it could be in inverter array. No? Hmm.
Oh no, I'm sorry, fish.
What's the deep purple logic again? XOR, right? Yeah. So that's an XOR gate, and then we'll go in a bit more. Zoom in.
Why my brain struggle with this? Why my brain struggle?
When in doubt, read.
More caffeine.
More
Oh, dude, that's probably a
caffeine
good
is a
idea. I have barely had any today.
And if you're hitting a wall, there's always the bowler pig, right?
Alternatively, get up and walk around your apartment.
That's what I'm about to do in a second.
I don't know, buddy. What is that?
Okay, so I have a 5 foot when it comes in.
Are you still streaming?
Me?
Is anybody still streaming?
Yeah, Kappa's still streaming. An incrementer? Oh, that's bullshit. Screw you. I'm joking.
Yeah, I'm streaming on YouTube.
I don't know what that is.
Wow.
That's a decoder. Yeah, that's a decoder. It's a decoder.
I think I have to readjust this pipeline. I don't think this works. Not in the way that I want it to cleanly. So if I delete this, well, no, I want that. Just delete this.
How's the lithography going, Ali?
Huh?
How's
No
the
one's talked about that
lithography?
shit in a while.
Oh my. Don't let dreams die.
I don't got tools.
Fair enough.
Heck yeah, baby. I just tested the Rails emulator rewrite and it's a work add-in.
I looked at that
Congratulations, motherfucker.
Time to write it in Verilog.
You should consider not parsing ASCII instructions and doing binary before you start the Verilog.
What do you mean?
At least what's currently on GitHub, you're opening up a file and reading ASCII, right?
Yeah, it's just text. Well, it's assembly, and there's an assembler which generates not like
you
binary,
do
but
convert it. Oh, no, but yeah, you need to. Machine code and instruction encoding is a big part of it. Like, it would help you a lot if you were to write an assembler that outputs flat binary files that you could then emulate, and then you can compare that versus, having it in the abstract syntax tree.
Well, the assembler, it like halfway does that. The assembler converts it to a vector of vectors of integers. And then so the only really difference is the base.
Whenever someone calls a dynamic or a vector, because C++ does that, right? I just get mad, and that's why I don't use C++.
So it basically already is.
Yeah, that's good. Another useful thing is to write a piece of code that concatenates a ROM file that is effectively some Verilog. That's just a hard-coded ROM with a switch statement, so you can easily test your assembly. Yeah.
I had to turn you up. You're kind of quiet. So what was the last thing you said?
Oh, so what you do is you make a ROM module in Verilog initially, because it's just very easy for testing, where the memory is effectively one big switch statement. And
You know what's easier than that?
Tell me.
Just plugging the shit into Verilator and having Verilator, your Verilated test file, just feed in data
Oh yeah, I do
from
that.
a text file.
That's what I do in my CPU. But yeah, I mean you can do that as well. I have a pretty neat tool in that takes generates IMGUI UIs around all the modules.
Sweet.
Yeah, it's a really cool tool.
That allows you to like play with the inputs and outputs of the modules in real time with a what do you call those diagrams? You know, the one timing diagrams. There you go. The word escaped me. Anyway. But yeah, you just need some way of getting the flat binary of your assembly into your processor for now, so that you can program test things.
Cold and wet.
That's going to be interesting.
What?
Getting the CPU made in System Verilog and then like creating a way of comparing its results to the emulator. Like automating that too.
Mm-hmm.
Dump,
Yeah,
write the files to dump your emulated output to VCD.
Yeah. You could also, like every clock cycle, print to the terminal the registers and the CPU state in Verilog, and then do the same in your emulator, and then just do a def on the two text files.
I mean, hell, like your CPU emulators in C++.
Yeah.
Import that shit into yeah, just importing into the Verilator, into your Verilated project file, and then just like, are these different every
Just to be more specific, Verilator is a program that compiles Verilog.
We talked about this already with him.
yeah.
Oh, okay, cool. Yeah.
Well, I wouldn't mind another perspective.
It just takes your Verilog code and translates it into C++ code that it then compiles. And then, yeah, so it's useful because what you could do is if you were to So right now you probably, I don't look at your code in too much detail. You probably have a big while loop somewhere or a for loop or whatever, where and then you're switching the opcode, and then you know, doing that on whatever the state of the CPU is, whether that be memory or registers or whatever, which are just variables in your C++ program. What you could do is write the code to be more clumsy and silly, like overcomplicated, to more strictly follow your system diagram, similar to what Kappa is drawing now, but just for your CPU. And then you can model those modules so that they are the same as the C++ code for your emulators. Modules are very much modeled around the same pattern as the modules in System Verilog. Then you could swap out parts of the CPU with actual C++ code that emulates the rest of the CPU, thereby eliminating the multivariable nature of having all these different building blocks and modules, and only testing one at a time. So the entire CPU is emulated except that one block is actual Verilog. Or if the entire CPU is Verilog, but some of the blocks are C++. And that's also another way of going about the problem. But it's not very practical on a large scale, because you're effectively building a CPU twice, which is absurd. But your CPU is very simple. So you could do that as an educational journey.
Very interesting stuff.
What's interesting?
Barely.
Oh, yeah.
The $1 million question is, where the fuck do I inject my run-ahead instructions? What's the most optimal place where it results in the least amount of state needing to be tracked?
In your belly button, you have the most veins there.
So about belly buttons, I cannot be touched in my belly button.
Same.
It hurts. And I will literally just scream in agony and want to like punch. It's like an instant reaction to like punch or shove away anything that gets near it.
Pain?
If someone,
Yes.
yeah,
My
like,
entire
it
life.
hurts.
It's brutally painful if I
hurts.
touch the inside of it myself.
Yeah, same.
But you're when you were born, your doctor fucked up crimping off your umbilical cord, because that shouldn't be the case.
Yeah, no shit, it shouldn't be the case. I'm the only person I know that's ever happened. I know it's an issue, but yeah, I can't get touched in my belly button. I will literally I just can't. Maddie thought I was joking, and she went and touched it one day, and I like curled up, and like 2 tears came out of my eyes when she poked it, and I'm like, no, literally, that's like, I'd rather you punch me in my dick. Honestly, it hurts. It is the most painful thing in my body.
Yeah, that's not fun. I have some.
Yeah,
if
that's
someone
not good.
tickles me, I will bite you. So don't tickle me. Goodbye.
Oh, that was quite the exit.
No.
Why?
RT left.
Oh.
Oh no, I'm
if
still
you
here.
tickle me, I'll bite you. Goodbye.
Yeah. So, you still haven't answered my question effectively, Ali.
What?
Describe your emotional state.
You know, it's going.
Oh, what's going?
You know, life. It's going.
Define life.
Yeah.
Hey, Data, you know what's something that's also pretty cool from the Verilator thing?
What?
You can replace your RAM module with malloc. So then you
Yeah.
effectively have as much memory as a computer in your virtual CPU.
That's pretty cool.
Where do I want to run ahead? If I inject down there, I need to read my register values, so it needs to be above my register file. But
Bye, Ellie.
Hey.
Oh no, Ellie's back. Kappa, have you
What?
considered adding instructions to multiply matrices?
not on this system. I don't really need it. It's not made for that kind of stuff. If you want to do that, you have custom instruction space. Add it to yourself. It's made for you to add variable like timed accelerators. That's why you'll have the whole dirty register thing. So if you want to do it, just make an accelerator for it and mark the result register dirty while you're out.
Yeah, my bar. Make it yourself.
I might actually do that. I want to do software rendering on this. That sounds like a fun time.
Yeah.
No?
So let's yeah.
I'm tired.
I need to call my doctor's office today and be like, yeah, I need to reschedule. But I don't want to call them right now.
Why do you need to reschedule?
I rescheduled them getting my blood like last week, and then my car wasn't running to go and get to my rescheduled appointment, but now it's running.
How does that work in America? How do doctors go about collecting blood?
You go to a lab, or sometimes your doctor's office will have a lab, but it's not a guarantee.
Interesting. Yeah, we don't. So doctors don't have labs here, but there are labs, and you go to the lab. They're generally in the hospital complex.
Yeah.
Yeah. So like the doctor doesn't have one in their office, but there's like hundreds of doctors in one place, right?
Yeah.
And then the lab is there.
Yeah, that's what I was saying.
Okay, same thing. Fair enough. Yeah, and then there's like a bunch of bleeding rooms, and you just go sit, and a nurse kind of just, takes your blood.
Hello, Emil.
Yes.
Time for your blood.
Oh yes. It's actually called the bleeding room. That's alarming, isn't it?
That's awesome.
Yeah.
Come to the bleeding room, please. We need you to bleed. Trust me, it is for your own good. Just listen to us.
It's a controlled form of bleeding, okay?
Get down here, it's just called the phlebotomist.
It's the bloodletting room.
Oh
The
my.
bloodlet.
No, please don't kill me. Seriously.
Why did I remove... I'm trying to remember my dumbass reason why I removed this from up here. Like, why did I move this?
How cool would it be to work in a candy shop?
Bling, blink, 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 blink.
I'm gonna have to relearn how to use the Windows Linux subsystem to use Verilator.
Capo, I vote to ban Data.
Why?
What? I never have had to use it. If I ever need to use Linux, I just fucking SSH into my fucking...
Oh, I use the Windows subsystem for all my stuff.
What's wrong with
I
you?
have not.
That's how I get. That's how I get like iVerilog and like it goes Verilog system, SV to V and stuff. They're all running in Debian.
Just use Verilator. I swear, dude, that shit's so much better.
I'm going to. I think what I'm gonna do. I'm open to feedback. I think I'm gonna do what Myvar said and make the CPU in Verilog and then set up Verilator to be able to like swap out modules with just the raw C++. With the emulation in C++. I think I'm gonna do that.
Well, Rails is so simple. You literally don't need modules. You can write it in one file.
Oh, well, in that case,
I wrote it in one module.
Yeah, you don't need
Alright.
much.
well then here's what I'm gonna do. Then how about this? I'm gonna make it in Verilog, and then I'm going to set up a system so that it also automatically builds it and tests it against Verilator, the emulator against Verilator, and test the outputs and if they're the same, yada yada, all that good shit.
You can import your emulator into Verilator.
Or maybe I should import Verilator into my emulator.
And
That also works.
doesn't Verilator take over the build process?
Yeah, but you still just point it at a C++ file.
Yeah, but it's not that simple. Like I guess technically you could think of it as you're pulling Verilator into your emulator, and not the other way around. But I mean, Verilator is still taking over the entire build tool chain, so you know.
What do you mean it's taking over the entire build chain? Is it not a library?
No,
It is a library, but
Do you not
You know.
import it into a C++ project and then like use functions to target like Verilog code and turn it into
Yes.
C++? Okay, well then it is a
kind of,
library.
yes. It is technically a library, but it's also not. Just use it and you'll understand. Yeah, just make a blinky or something where you're blinking an LED, and then it will.
it's got
it'll
its own
make-
command. It's got its own build.
Yeah, it's
Oh boy.
yeah, just whatever.
But once you generate the verilated project files, I imagine there's some way to incorporate that into a larger project.
I have tried. It's fucking nasty.
You've tried, okay.
Yeah, like it's possible, but ew.
How much C++ have you done?
Who are you talking to?
I'm talking to you.
I don't know a lot. I wrote a few compilers in C++, but that's about it. Mostly C. Yeah.
Didn't you write that whole text rendering shit in C++?
I wrote it in text rendering in C#, C++, C,
Ah, shit.
and Jai. Like I implemented 4 or 5 times.
Wild.
Yeah, but yeah, that was in C#. The YouTube videos are in C#.
I like the getting started under verilating in the documentation. Verilator may be used in 5 major ways.
You can be Verilate in your Verilator, which is Verilate.
Sounds violating.
I looked at like expanding Icarus Verilog. They do have a plugin system thingy, but it doesn't seem very
Fuck Icarus.
expansive.
It
Yes,
supports so few things.
Actually, fuck Icarus.
I've kind of just given up on System Verilog, and I've been running my own HDL like the last few months.
No, System Verilog is Bay.
Listen,
I mean, it's not, but
Says you.
yeah, says me,
Fucking troglodyte.
bitch.
calm down.
You called me troglodyte like yesterday or something. I just decided to throw it back at you. This should work.
Okay. Oh, okay. So it's not a library, it's a tool that you use.
It's
It's an
technically a
application that you use.
library.
Like,
Like
technically
it
a
takes very
library.
yeah,
It's a
like
tooling
it takes
library.
very
all right, so
yeah,
this is epic. So what? Okay, so what I'm just gonna do is I'm just gonna have my program. Ooh, I'm gonna need a. Okay, here's what I'm gonna do. I'm gonna have a parent program that runs the command and then compiles another C++ program that incorporates the C++ that Verilator generates into it. And then the daughter program will be able to do all the cool shit that I'm thinking about.
yeah. You
That's
can
how
do
we're
that.
gonna do this, baby.
I have done that. So that tool I was talking about parses. I wrote a parser for System Verilog. So it parses out the Verilog, reads out all the module headers, and then generates a bunch of C++ programs that can then be compiled to then have the OpenGL backed IMGI UI to play with the modules.
Mhm.
It's Rail and actual CPU. Yeah, like architecture.
Define actual.
Like, is there like a standard for it, or is he just doing his own thing?
Well, it
Sorry,
has
what?
been implemented in an FPGA once before, so
You never put on an
Um,
FPGA.
what?
Wait, I forget? Did you actually run Rails on an FPGA?
Yeah.
Oh
Oh.
my god, I forgot about that. That's fucking awesome.
Like, where does
That was
Rails
my-
come from?
It's just something Matt made up for it to be an easy CPU to learn in Minecraft.
Oh, okay, is that where it comes from? I see. Yeah.
Same origins as pORC, but a lot simpler. Like it's made for like someone who doesn't know CPUs versus pORC is made for someone who knows CPUs.
Rails instruction set architecture. I designed this ISA for minimal implementation complexity while still being practically capable of general computation. There are 16 instructions plus 3 pseudo instructions. Each instruction has 16 bits and there are 2 encoding formats. The instruction set was heavily inspired by RISC-16, developed by Peter Chen at the University of Michigan. That is Rails.
Nice. It's a very simple instruction set. Oh yeah.
Okay, so we have China, France, India, Israel, Pakistan, Russia, the UK, and us.
But yeah,
I'm really.
I did
bad
get that
at
shit
it.
running on an FPGA. It worked out pretty okay.
What does that mean?
It worked.
It doesn't sound like it did.
I used to buy an
It
FPGA.
sounds like there's probably something with the way that like it operates that made it like annoying to code or annoying to do something. There's some annoyance or something. Sounds like it.
No. Like, it worked. I ran fib.
Like or classic.
Or classic. It can run fib, but not an equally complex program such as Scalats.
Yeah, I had to work out some bugs like right after you did that, and then I also just worked out like a few other final bugs like just now to earlier today.
I don't know what I was thinking. I think I just had temporary insanity when I said that we could move the Runahead queue.
I wonder what is the like most simplest minimal compact instruction set that Clang has a backend for.
I think it might be RISC-16.
Is there a Clang backend for that?
I know C. There's a C compiler for it. But I mean, knowing the internet, the fucking x86 move instruction, there's probably a compiler out there for like a single instruction set. People make weird, dumb stuff like that all the time.
Yeah, but like that's at the, oh, here we go. There's like a bunch of architectures here, but not familiar with most of them.
Oh my god, I just realized something. When we made the forwarding system before, we had it forward the load, and it's literally impossible for the load to ever be forwarded in this stage of the pipeline because of the way the dirty bit works. It's just an actual impossibility. That's cool. That simplifies the forwarding system a bunch. Okay, I'm happy with this pipeline now, I think. Everything should be covered and good. So everything sounds good. The only thing I'm gonna think through this one more idea to make sure that the pipeline works with this, and then I'm gonna call it for the day on this. So that's some shit I need to do.
So, according to the internet, one of the smallest targets that GCC supports is Moxie, which sounds like a drug. And then ZCPU is apparently also pretty simple.
Hmm.
Oh, ZPU, I guess. Where's the spec though? Oh shit, that's fucking complicated. Oh wait, no. I'm stupid. Am I though? No. There's a website called Open Cores.
Yes, it's not that good.
I see that.
I mean, it like the resources on there used to be really good from my understanding, but like every time I go on there, everything either has some like weird license restriction, or it's like 20% done, or it uses the like a really bizarre standard that has like no documentation. It's like, hey, I made this controller, and that's it. I feel like his intentions were good and everything. The idea is amazing. It's just I think it just lost. Like people just stopped going to it and using it.
For what?
Oh, this is interesting.
Open cores.
So I think it would be pretty straightforward, or well, famous last words, right? But it might be possible to take Moxie or CPU 0 and translate its machine code to port code, and then have a working LLVM or GCC toolchain. But I don't know. Like
Well, pORC is made to go one-to-one, near one-to-one instruction translation from RISC-V. It just has less registers.
Yeah, but that's not hard coded, right? We could increase that. Like it
No,
would be difficult.
you can't just increase register count.
The thing is, like, it would be difficult to like if there were more registers than in RISC, it would be easier to deal with than if there's less, because the understand. I think I explained that like my backside, but
We can just tell the compiler to not use the upper registers if that's possible.
I don't think it is, or it might be, but I don't know how.
If you could just simply set a flag that says, hey, only use the lower registers, then bingo bango.
Yeah, no. Where's the one instruction set compiler? That's garbage. Well, it's not fair to say it's garbage, but
Mob
Bruh.
Skater.
bro. Oh wait, no, I think I'm misunderstanding this. Oh, that's interesting. This is actually quite interesting. Just like, you know, and slam it till you try it. Could you literally implement an entire program using just that? That is wild.
Yep.
Do what?
There's the one instruction. Like I thought it might be an instruction, and it takes an argument that's just another instruction. But no, it's literally a single instruction, and by properly manipulating its logic, you could, you know, compile to it.
Like, are you talking about like sublec and stuff like that?
I don't know.
Um,
Here, I'll send you a link to what I'm reading.
yeah, because one instruction set, it's really cool.
It is.
Yeah, that's exactly what I'm talking about. Yeah, my boyfriend got like most of the way through designing a subneg computer and got boards printed and soldered up.
Cool.
It is very cool.
There we go. I like this diagram a lot now.
One made a Ciblic like game, like programming game. That's wild.
Okay.
Oh, I see what you're saying. Yeah, the mov instruction is literally Turing complete. That is hilarious. But the mov instruction is complicated, right? was a fun rabbit hole, but I have to go. So goodbye.
Okay.
Bye.
Bye.
Right.
Okay, I'm liking this now.
Oink oink.
Pork, pork. Pork, pork. The beautiful thing I love about branches and stuff like that is that I can detect whether or not it's a branch by only looking at 4 bits. Well, I need to look at a total of 6 bits. If the upper 2 bits are 1, 0, then I know it's a branch or a jump. And then I just have to check if the LSB, then if bit 15 and 14 are 1, 0, then if bit 12 is on, check bit 11 and 10 to be if they're 0. If it's bit 12 is off, then check 8, 9, 10, and 11 for 0. Because if those are zeros, then it's unconditional. And this is all in one stage on purpose. So it's just like its own stage. The very first thing that happens to an instruction is it says, are you a branch? And then it changes a speculative program counter, and it tells the speculative program counter to like store like a recall point. Which means this needs to be a 2-directional communication. Oh, well that's lame. Thank you for telling me my audio is only mono. Huh. Weird. Testing, testing. Hello. Oh no, that's weird. Properties. Yeah. La 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 la. Okay, cool. After Myvar DMs me to let me know if you can hear the stream, I'm gonna call it end this shebang. Damn, still mono. Oh well, I'll fix it later.